function valued at x0, x1 and x2, okay, 3 points, then I have a second order polynomial. And then the way I would use in the nested form would be just to say that my function is actually equal to f of, my function is actually equal to, I start from this and I'll say f is f of x0, x1, x2, okay, so that's what I would say. That's what I call here by saying b1 equal to an, okay, right? And then I go to the next point, so it's n in my particular case, in n was just 2, okay, so then I'll go to the next one and I will say that I will multiply that n, okay, that's I is n minus 1 here, so actually I plus 1 is n, okay, so that is my function here. I multiply that by z minus the function by the value which I knew this, okay, and then add the next coefficient to it. Okay, that is saying that the next step, this is the first step, and the next step I would do, I have to compute, then I have to multiply this by that, so I'll multiply x minus x1 with this coefficient f, okay, that's what I did, okay, and then I add the next one to this, that is f of x0, x1. Okay, so that I get, and then the next step I would take this f, okay, this whole coefficient and multiply that by x minus x0 and then add a0 to it. So that's what is here. Okay. So the term before that, you multiply that by x minus x0 or x minus x1, whatever that number is. Okay. So this is now my new f. Okay. And then I take the next f, I will take x minus x0 and multiply f and then add a0. Okay. So that's the step 1, step 2, step 3. Okay. That's what it is here. Okay. This is exactly what is been given here. So you can write this down and then try to do this by substituting numbers here. And you can see that this is exactly what I have written on this board here. Okay, so that's now I give this a small problem here which we can work out that, or we will just do that here. So we have, let's say, a function value, a function given at x 2.5, 3.75, 5 and 6.25, and the function values are given as minus 28.62, 159, 513, 1265. Okay, so we have 1, 2, 3, 4 points at which the function is known. Okay, and then we want to construct a polynomial which goes through this using Newton's divided difference method. So we will get a polynomial of order 3. Right? So what we get is a polynomial of order 3 because we have 4 points here. So we'll use this form to actually we will use the form which is given here, okay, to compute this function of order 3. So we'll substitute actual numbers for this and then we'll just go on with this calculation.